All right, welcome to the last lesson of the cadastral mapping lessons. So we're going to talk about geographic information systems, often referred to as GIS. So there's one thing to note before we start. I'll be using ArcMap to demonstrate that. I assume that's what most of you are using, but some of you may be using other things. And so if your county is using something aside from ArcGIS, or if they're using a third-party extension to that, to be inside of that, to draw your legal descriptions, if you're using AutoCAD or other things, just note that it might be done differently, but a lot of the principles could be the same. So as you go through some of these, if you're using a different software, just realize that the principles, and you may need to have your county create the specifics for the details on what and how you do it. But I'm going to show you using ArcGIS, or ArcMap as it's often called, but we're going to use the Esri product to show you the GIS. That's the one I use, and I'm guessing that's the one that most people use. It's the one the state uses as well, from the AGRC, the Automated Geographic Reference Center. They use the Esri, the GIS product. So let's talk a little bit about GIS. As I mentioned, GIS stands for the Geographic Information System, and so for a long time, maps and things have all been hand drawn, studied, and things like that. But in the past 20 years or so, it's become possible to put those in the computer. And so as the computers and things get better, the maps and the way we create them become better as well. And so a geographic information system, or GIS, integrates the hardware, the software, and the data for capturing, managing, analyzing, and displaying all forms of geographically referenced material or information. It's important to know. So that's the basis of what GIS is.
GIS stands for Geographic Information System. Using computer hardware, software, and a ton of raw data, we can explore the fundamental principle of geography, that location is important in people's lives. Using GIS, we can view, understand, question, visualize, and interpret data in visual ways that reveal relationships and patterns, which allows us to make better decisions. For example, a meteorologist might study the paths of hurricanes to predict where and when they might occur in the future. A city planner can choose the best location for a new park or hospital, ensuring that they are built in the place where they're needed the most. GIS is essential to understanding what has happened, what is happening, and what will happen in geographic space.
But GIS provides the ability to establish specific spatial relationships between individual sets of data. Okay, and so it allows us to do that. So a lot of what we do is it becomes a powerful tool to help meet the needs of the mapper, the cartography, and gives you a wide variety of applications and disciplines and a way to do that, to solve some of the problems that you might have by hand drafting. We're going to talk a little bit about some of the tools that you can use. We've talked a little bit about a lot of our mathematics, calculating acreage, things like that, become very simple when you involve the computer, because it does all those calculations and other things instantaneously for you. But a lot of the data that we get in the recorder's office that's used to generate the parcel, the land the divisions and things, varies a little bit in different counties. But some of the methods used to input the data into the GIS for land divisions would include documents such as warranty deeds, quitclaim deeds, other things, subdivisions, annexation plats. Sometimes you might get an AutoCAD file to import into there, and even sometimes we'll use text files that contain a saved traverse. But all those are methods of inputting the data into the GIS. But something very important is that documents are usually the source of a legal description, and the GIS parcel data should never replace a recorded document containing a legal description. The legal description on that recorded document is the official record, and GIS should never replace that. That's something I can't stress important, that the official record is that document that's been recorded. So even though that's what we use to create the parcel database. The plat is just a visual representation of that deed created by a surveyor, engineer, or a county cadastral mapper to show the bearing and distance of each line and curves on the plat. Some important consideration when trying to determine if you want to use GIS versus that, cost is a major factor, and what type of software you're going to use on the computer. You got to figure out what is the cost to benefit analysis, the purchase cost, the maintenance cost, storage costs, other things. Also the burden of data collection, training, things like that. If training is your issue, hopefully this video can help them, or they can we can work some things out and show you a few tips and tricks to help do that. Hopefully you'll learn some of that in here. But another very important thing that we need to remember is that the GIS parcel layer does not replace a survey. It doesn't take that place, but it only represents the parcel boundaries. So a surveyed parcel, that survey record always holds precedence over that. So let's talk a little bit about inputting the data from the documents into the GIS system. We call that coordinate geometry, or COGO. So COGO is an acronym that stands for coordinate geometry, and it's a method for calculating coordinate points, survey bearings, distances, angles, it's also an automated software used in land surveying that calculates the locations and distances and bearings from known points and references. A little bit about the history. COGO was originally started in MIT as a civil engineering system, developed in the 1960s. It later evolved into a suite of program used for civil engineering and solving those problems. And then in the late 1990s, Esri had a GIS extension for ArcGIS that was called Kogo, that had a set of tools containing mapping that basically helped what we do as cadastral mappers for mapping the distances and bearings from legal descriptions and calculating closures. The nice thing about that is that Kogo, that GIS extension known as Kogo, is now included in ArcGIS, and that's on the Kogo toolbar, just as part of the normal part of the ArcGIS software. The best way to describe Kogo, and the simplest way, is that Kogo is the capture and automation of bearings and distances to create GIS data. Simple way to define that. But to further that, it stores lines and curve data along with X and Y coordinate values. A lot of this is in the background as it's doing it, but it stores all that attributes that pertain to the angles, distances, directions, and the measurements, and they're shown in whatever format you use. We use the quadrant bearings, degrees, minutes, and seconds, along with the displayed minutes. So the most widely used for us of the tools in the Kogo toolbar is the traverse tool. You can see that there's a picture of the traverse tool. It's that first one. It looks like the little a set of bullet points with the curvy line underneath it. That's the traverse tool. You can see a picture of it there. But the traverse tool lets you create and sketch multiple bearings and distances and calls from a legal description or a surveyed plat, and you pick a starting point and you can add or remove, reorder the lines. So if you've skipped a call in the description, you can go back and add it in, or rearrange them if you got messed up, stuff like that. Also helps you figure out some of those closing issues that you might have with that description. But the traverse tool will accept the directions and distances in a variety of formats. We'll talk about those. The one that we use is Quadrant Bearing. That's the one that most of the legal descriptions are written in. But we've got an example of the quadrant bearing here, kind of a cheat sheet. When I first am teaching cadastral mappers or my GIS guys how to enter the legal description using the Kogo, they usually have this little north, south, east, west with the quadrants and the numbers, and they usually tape it up there, and then when they start to remember that, then they eventually take it down. But the quadrants in GIS are numbered, so instead of putting in north and then degrees, it's in the quadrant. So the northeast quadrant is 1, the southeast is 2, southwest is 3, the northwest is 4. So you got 2 examples of a line here. So north 45 degrees 0 minutes 0 seconds east would be put in as 45-0-0-1, because northeast is quadrant 1. So similarly, if you were going the other direction, 45 degrees 0 minutes 0 seconds southwest would be 45-0-0-3, because we're in the southwest quadrant. So you could put that same in, so you put your degrees dash your minutes dash your seconds. In this example there are 0, 0, but you'd put in whatever those numbers were, and then dash whatever quadrant it's in. So we'll talk about that as we give you an example later. But the courses can be entered as straight lines with a bearing and distance. It can be entered as a tangent curve. It can be entered as any of that. So also with the Kogo toolbar, there's also an advanced editing toolbar that helps you clean up and contains a lot of the editing, modifying some of those parcel features. And there's an example. Several of the tools in that advanced toolbar are specifically used to create and edit parcel polygons that we created using that Kogo toolbar for the cadastral mapping. So let's talk a little bit about drafting parcels in GIS. Okay, so an important thing to note is that drafting parcels with GIS uses all of the same principles as drafting by hand. Okay, the only difference is the methods for completing each step are different, but all the same 6 steps that we talked about, they're all the same. We're going to go over those in a bit. But line weight and other things are important elements. They're used in hand drawn. Those same elements can be used in on a digital plat. You can change the thickness of your line to help show up or highlight whatever you want. The nice thing about making adjustments to the parcels and those line weights can be done, and so depending on what map you're doing, you can adjust those. You don't have to redraw them, you just adjust those things. Change colors, things like that based on the background, or other things on the map that might change that. So let's talk about those 6 steps. We talked about the 6 steps, with step 1 is the defining area, step 2 finding the reference point, step 3 getting to the start, step 4 the point of beginning, step 5 actually drawing those property boundaries, and then step 6 is rotating the description. So let's switch the setup here. Okay, we're gonna go over the GIS. We're gonna go over the drafting, meets and bounds description using the Kogo feature in ArcGIS. We're going to go over the same steps that we used in the hand drafting, the same 6 steps that we used. And so before that, we have to do a few things because we're in ArcGIS, similar to where you had to get your compass and your scale and your plat map, and you get that out. You have to get ready. So we need to start editing. Today we're going to edit our construction lines because we don't want to edit the parcel lines. We're just trying to draft to see if this description rotates and matches up to match with our parcels. So we're going to start editing our cadastral or our construction lines. So we're going to start editing those. You can see now some of our things, our editing tools are highlighted now, so they're available for use. So we're going to, step 1 is to determine the defined area. Okay, so the defined area that we're going to is according to our description, and that description on page 7-6 that we're using. It's the mathematically rotated from chapter 5, but we're in the northwest quarter of section 23, township 5 north, range 2 west. So this right here represents section 23 of 5 north, 2 west. Okay, so that's we've zoomed to that area, and we can determine which one it is. So we're going to go to this area right here. So that's the defined area. Now the reference point, which section corner are we using from? We have a couple different section corners that we know of. It could be one of the ones we don't. But according to the description, we're going to go from the northwest corner of said section. Okay, so the northwest corner is this one right here. So this corner here, the northwest corner. So we found that. Okay, so now that we know which corner, we know what area we're going to be in. I'm going to zoom in all the way in here, and my zoom is a little backwards, so if I zoom the wrong way, that's okay. This is a different computer than I usually work on. But let's open our Kogo tool. So I have my Kogo tool. So my editor tools are all here on the bottom. You can set up whatever way you like, but your Kogo tool is this one. It's called the Traverse tool. Okay, and that's in the Kogo toolbar. So let's open that Traverse toolbar. If you haven't set a template, you'll want to set up a template. Like I said, we're going to use our construction lines. You can click this, and you can see the ones that we're not going to edit the section data. We're just going to edit our construction lines. In fact, let's turn off. Oh, that's all. It's there. Okay. So now that we have that, we're going to use. We know our corner. So let's start that reference point. So I don't know if you see that. You see the start point right here. You get to select the start point. Okay, so I just clicked on that button. It brings up a place, and so I can, and it snaps to it. See right there, it snaps to the section corners. So I snapped to that section corner. Okay, now we get to actually do our drawing. Okay, so let's go through this. Step 3 is getting to our starting point. Okay, and I have this. We set up. I should tell you this. Let me close this, and I'll show you how we did this. So in the editor, I don't know if you've done this, but under the options, the way that I've done it is under units. Ooh, see? I'm glad I checked this, because this would have been totally screwed up. The direction type needs to be quadrant bearing, okay, because we're going northeast. And the direction units need to be degrees, minutes, seconds. Okay, so if those aren't, if you had it, if the default is the polar, that's 360 degrees. Mostly our descriptions are not written like that, but and they're not in decimal degrees. They're usually in degrees, minutes, seconds, and the quadrant. So it's a good thing we checked that. So if you're having issues and it won't go in there, check that. It's in the editor and your options. Okay, so we're going to hit apply, and we're actually going to stop editing, and then we're going to start editing to make sure that those changes are applied to what we've done. Okay, so we're going to open our traverse tool again, come down here, pick our start point. We're going to start on the section corner. Okay, so then my direction distance. Okay, so the direction I want to go is south 10 degrees east. So I'm going to go 10 degrees, and I'm going to put a little dash there. So the way that the directions in the Kogo is set up is you put in your degrees, then your minutes, then your seconds, and then your quadrant. Okay, so 10. And we're only going 10 degrees east, so we put 0, 0, and the quadrant is southeast. Okay, so if we number them, so our northeast is 1, our southeast is 2, our southwest is 3, and our northwest is 4. If we're going southeast, it's going to be 2. Okay, so it's just the way that the ArcGIS is set up. It just numbered them clockwise around there. Okay, so that's our direction. We can hit tab, and then it takes us over to our distance, and our distance is 106.37 feet. 106.37 feet, and we just click add or enter, whichever one. And we have our first bearing. You see that bearing showed up right there. So that's our first one. The next one we go through is north 80 degrees east. Okay, so we're going to type in 80. And if there's zeros, you can skip, and it'll know that the last one is just your quadrant. So I can do 80-1, a little shortcut, or you can type in the zeros if you want. So it tells it's 80 degrees and it's in the northwest quadrant. You can also hit the plus arrow or the plus key, and it'll jump to the other box instead of hitting the tab. But we're going to go 72.48 feet. 72.48 feet, and we're going to hit, and we're going to add. Okay, so we see there that takes us to our starting point. So that's our point of beginning right there. So just the same as we were drawing it by hand. Okay, any questions so far? I'm going to move this over so we can see it a little bit better. I don't know if you can see those lines there that we have. Okay. So let's go back here. Okay, so now that we're at our point of beginning, we're going to move excuse me, that was step 4. Step 4 is that's our point of beginning. So this is the point right here. This dot right here. That's the point that we're going to try and get back to. Okay. So as we draw our description, that should be our beginning point and our ending point. These first two are, like I said, are just the first there. So let's do the property boundaries. Okay. So the first one is running thence north, 63 degrees, 44 minutes, 45 seconds. So we're going to type in 63-44-45, and it's northeast, so that's in quadrant 1. Hit the plus key. We're going 75 feet. Hit enter, and there's our first bearing. And then we're going south 26, 15, and it was southeast, so that's 2, and we're going at a distance of 120.87 feet. The nice thing about the ArcGIS is it'll do the math for you. I was talking with one of the other recorders and showing them how to do this Kogo thing. And so if you have one description that's in rods or chains, you can actually put in RD and see how the add box over here is in blue again. So that will take it 120.87 rods instead of feet. You backspace. It's always going to assume there, but you can put in C. See, when I start to put in the C, the add button is no longer highlighted. But if I put an H, it's going to say, okay, that's chains. So it'll automatically switch those to whatever unit of measure that you're using, and it'll calculate the difference and obviously put it into feet. So you can draft your description as it is. You don't have to do a lot of those conversions from things, but this description right here is all in feet, so we're just going to leave it the blank and add it there. So we have our 120.87 feet. We don't want to go chains or rods because it will be we won't come back to our point of beginning. So you can see, you can also see this, the red dot. The red dot changes where it's at. That's this last thing. And if you've ever screwed up on a thing, you can see, you can highlight it. Oops. And it'll flash. So as I highlight it, you can double click it. And so if you've typed it in wrong, you can go in and change it to make sure you've got your description entered correctly. If you've skipped one, you can add it at the end and then bump it up to make sure it's in the right place. But let's continue on. So now we're going to go south 70 degrees west. So 70 degrees southwest. And we're going to go 75.45 feet. .45 feet, and then we're going to go thence north 26:15 minutes 15 seconds, and we're going northwest, and we want to put in a distance of 112.65 feet. And we can see that we end up right here, back to our same point of beginning, right there. So if it doesn't, let's say hypothetically that we messed up on this one and we actually shorted it 10 feet. Okay, see how it doesn't show up there? we can go through our description and say, okay, where did we screw up? Why didn't it close? And you can say, oh, I accidentally typed in 65 instead of 75. You can change it, and it adjusts on the fly. Now, before we hit finish, okay, this is a little different because this is our completed description. We did go back to our point of beginning. Before we hit finish, we want to save our traverse. In case you ever have to redraw it, redo anything, we want to save that. And you only have to save it for a few days, but while you're working on the project, it's nice to have it saved. So I'm just going to right click anywhere in there, and we're going to save that traverse. Okay? And we can save it to wherever we want. We'll just save it here, and we're going to use this as our example. Okay? So if you ever wanted to do that, you could also right click it and load the traverse, and you can see it'll pull up that example traverse. So if you ever want to do it before you type anything in, right click, load it, and it's all there. You don't have to type it in twice. It's really nice if multiple people are using it. If you're Cadastral Mapper, if you are drawing the description to check it, and then the GIS team is actually editing the parcels and doing things like that, they can pull in your traverse, or if they've drawn something that's a complex description for you, they can save the traverse. You can pull it in, and you can see it and manipulate it there and rotate it or whatever you need to do for that. So once we're done, we're going to hit finish. There we go, redraw. Okay, so there's our drawn parcel. It's 10 degrees rotated. You can see that. Let's turn on our parcels and see how that matches. Okay, so we've gone through all of step 5. It's highlighted. So step 6, rotating the description. Okay, this one we talked about in chapter 5. We talked about rotating it mathematically. That's where we got this description. We've talked about rotating it manually in chapter 6 when we talked about rotating it by hand. GIS, you rotate it manually, just like we did when we drafted by hand. But this one is a little different because we have snapping and we can rotate it, and it just actually makes it really simple. Okay, so we're going to close our traverse window because we don't need that. We've already finished drawing it. And now we're going to use this rotate tool. Okay, so the rotate tool, my rotate tool is right here. It's the little round thing. You can see that. So we're going to click that. You see my icon, it changes there. Okay, you can follow along what I'm doing here on page 7-12. So this is it. There's always an X. Okay, the X represents the center of whatever is highlighted. Okay, so you see that my X is right there. It happens to be right there, and as I hover over that X, the icon changes. Okay, you see that? I've drawn a little bit about what it is. It's a box with arrows pointing in all directions. So we're going to hover over it, and we're going to click it, and we're going to drag that X up to the section corner, and see how it snaps there. See right here, it says it's along the construction line edge. And now it's a section edge. Section corners point. Okay, so that's the point that I want to do that. So that's where that rotation. Okay, that's going to be the hinge of our rotation. So I've way rotated it, but that's okay. If we're going to do our snapping, okay? So our snapping, if you don't have it, oops, we got to go back to our rotation tool. Okay, there should be there should be a plus symbol. If you don't have that, the X, you can hit Shift and S, and that'll show up. Then it should show up every time after that. If not, just you can toggle Shift S to toggle it on and off. But that's our snapping point. So the axis of our rotation is that should always be the section corner. That's the point that we know. That's our known location. So let's take our snapping point and let's put it on the end of our first call. Okay, you can see that as it snaps there, it's the construction line's endpoint. Okay, so this line right here, that first 10-degree bearing that we drew, is the one that we want to rotate to match it up with the section line. Okay, so one point is already on the section line. It's at the section corner. So if we use that, and we can click anywhere, and we can rotate, and as we rotate, that point is going to snap to that section edge. And see, as I move it just a little bit, see how it stays rotated? You can also see that as we rotate it, it matches up perfectly, well, with our drawn parcel. Okay? So let's turn off the highlighted, and you can see the little purple line comes now straight down the section line. So our description that we drew now matches the section line for everything else that we've drawn in the section. It comes over and it follows our parcel exactly, even though it was a rotated 10-degree description. We know that those were the same, but we've rotated it to match, and now we know that it fits. This one doesn't require break off, anything like that. One thing to note that's important is that there are classes online from Esri to be able to take some of these classes and to help you with the Kogo and things like that. And so you can take some of those on there. I've got some examples in your book. But an important note is to use that if you're using a third-party extension besides ArcGIS to draw your legal descriptions, you'll need to get specifics on how to draw those and do that, and to rotate the parcel description from your office. So that's drafting parcels with GIS. So the one thing you want to make sure you do is save your edits. When you're done, make sure you save your edits. So that's it. Okay, welcome back to the light. Okay, so we've talked a little bit about how to show you that. We've shown you some of the tools, a lot of the editing. We showed you how to rotate that description. Really nice how you can do that. Saves a lot of time, makes it a lot of simple. And we've talked a little bit about how the computer has made some things simple. We showed you all the rotate tools. There's some other nifty tools that we can do. And let's see if we can show you some of those. I want to show you the calculate the acreage tool. We've talked a little bit about how to do that. We've calculated the acreage in the math, but the GIS will do that very simply, very quickly. So calculate the acreage tool. Also measuring distances. So to measure a length, if it's an unknown length and you have that drawn, you can measure a distance. If you're doing a break off or calculating that break off or calculating a new description, you can measure that distance and know what that is, so you don't have to do the math. Calculating a bearing. Okay, let's show you how to calculate the bearing. So we're going to show you a few tips and tricks. The first, on GIS, we're going to talk a little bit about how to draw a curve. So remember the curve from the mapping example 2, page 6-4. We're going to do that. We're going to start our editing Oh, it looks like we already are editing. Okay, so let's go to our traverse tool. Okay, we have a template. We're going to begin on this corner right here, this same corner. I know that's not the corner from the description. So our direction and distance, we're going to start with a straight line, and we're going north 0 degrees, 13 minutes, and we're going northeast, which is in quadrant 1, and we're going 195.63 feet. Okay, which takes us to there. Move this down so we can see where we're going. Okay, so then that takes us to our point of beginning. We're going to go thence north, that same bearing, 362. So the bearing's already in there. We're going to do 362.81 feet. That takes us there. Then north 75, 56.26. Northeast, right? 140.33 feet. Okay, so then we come to a curve. So just like the direction and distance, we're just going to come down here to the curve. We have a couple of different options here. We could do a tangent curve if that's the information they gave. But we're going to go for a normal curve because that's what we have. So first of all, it says to the left. So we're going to change that. You can see these drop-down boxes. So it depends on what information they give you that you can put the information. But we're going to go to the left 260 feet along the arc. So let's do our arc, and we'll do 260 feet with a radius of 356. So let's change the radius to 356.37 feet. The chord direction is south 34, 57, 37, is that right? Yep, southeast. You can see now our add button shows up, so we're going to add that. There's the curve. It's looking just like it is on the book. So the next one is a straight line, so we go back to the direction and distance. And then we go south 29, 18, 36, and it's southwest. And we go 43.5 feet. Add that. Now we have another curve. So we're going to do this. So this time it's to the right. So let's change that to the right. And 317 feet with our arc. 317.16 feet. Radius is 295. 295.05. And our chord direction is 66 and 18 to the southwest. We add that in. That takes us back to our point of beginning. We could save the traverse. We've already saved it there. Yep. And then we're going to finish. So that's our polygon there. And that's how you draw a curve, just by changing this drop-down box there. So let's also talk about creating if we have lines that we don't know, there we go. So let's say we have just a line here and we don't know what that bearing is, and we're going to come this, we're going to come at a slight angle there so we don't know. Okay, so we have those two, and we don't know what the bearing is for that line. You can see here that we have the attributes and they're null. If we actually pulled up the attributes of one of the ones we did know, see we have our curve, there's all that information we put in. This one, there's that bearing and that distance, so we know that. But see, this one doesn't have anything. So there's a couple of things we can do to find that. So there is a measure tool. So we have this measure tool, and let's see what we are. The distance we're going to measure is in feet. Okay, so let's measure this construction line. Okay, so that's 323 feet. Okay, see that? 323.3.32 because it's 316. So we take that, but you know what? We don't know the direction. We don't know that bearing. You know, you could calculate that based on some of the information in the advanced mathematics class, but there's this tool right here. It says update the Kogo attributes. So let's click that. See, this line is highlighted. Let's update that information. So there's that bearing, and just like we measured, 323.316. Okay. Same information. Oops, we're trying to do the same one again. So let's select a new line. It has no information. We're going to update the Kogo attributes. Okay, so we have that information. Let's go back down to our parcel down here. Okay, so remember this one that we drew down here. So let's use our measure tool. There's a couple different things. We already know what this distance is right here. Okay, but let's change this to a polygon feature. Okay. So, and let's make sure we're actually, what area we're, you know, this would be square feet, this is square acres, so let's do square acres. So that we know, or the, excuse me, just acreage. So we can take this, click around our polygon, and it tells us that our area is 0.201 acres. Okay, you can do the same thing for any area that you want. It doesn't have to be that, so you can click that. See, that was 1.2 acres. So there's another feature here. So that's if you want to click a polygon, but there's also measure a feature tool. Okay, for this I'm going to turn off our construction lines, and remember this parcel that we had right here. So we have this parcel, we click it and it says, hey, I know what this polygon, the acreage is, it's 0.201, which is the same as what we got when we measured it with there. But if you have some complex things like we did, if we had a polygon in the shape of this, instead of clicking around here, you know, because it, oops, if we, you know, click this to kind of create things, you can kind of get what it is, but this isn't a true curve calculating the area. It's probably close enough that you could guess or put it in there. It's 1.38 or 1.738 acres, but if it was a polygon, you could just click that and it would give you the exact amount. It's going to give me the amount of what's under it. But So that's how you do both of those. Kind of some tips and tricks that you can use, much easier than finding out how to calculate those by hand. And the rotation tool, we talked all about that. A curve, measuring distances, calculate bearings. So a couple little tricks that makes doing the math and things not so difficult, because the computer does it all for you. So some of those tools can be used to make cadastral mapping much faster, easier, and actually more accurate than what we could do. Calculating the acreage, measuring distances, and calculating bearings are actually much faster and much easier, and in some cases more accurate using the computer to do that. There is some additional information that you can get. There's some training you can go to. So if you want more information, the best place to go is to training.esri.com. There's some training courses you can take there. Some of them are free. You can sign up and take some of those free ones there. Also, you can pay to take some more advanced courses. There's a couple of recommended courses that are offered by Esri. Introduction to Editing Parcels using ArcGIS Desktop 10, and also Managing Parcel Data using ArcGIS Desktop 10. So those are two really good classes. I believe both of those are low-cost courses that are available. There's also some ArcGIS Kogo tutorials online. Some resources also available by Esri. So there's you might be able to find some additional things on YouTube. I don't know what's out there. If that's how you found this video, welcome. Hope this was helpful. But something to note, again, I mentioned this at the first, but if your county uses third-party ArcGIS extensions other than the Kogo tool, because I know they're out there, a lot of people are using them. There may be some tweaks or differences in how you do those, and so your county may do things a little different, or you may use a different software altogether. But you might have to have some updates or be shown how to do those in your own office. I know there are some differences out there, and so I can't teach everybody how to do everything. This was just the basics that we've used that. So with that information, I have a little checklist, kind of a simplified checklist that we use. Or not a checklist, but more of a step-by-step outline on creating and editing parcels in ArcMap. We kind of showed you how to do the drafting, but this is kind of a 12-step process for creating parcels and doing those in GIS. So the homework that we have for the GIS, because not everyone has the Esri, the ArcMap, or the ArcGIS software, I want you to use, if you have some sort of GIS or electronic computer mapping, I want you to do the homework with whatever software you use. If you use the Esri products or have the capability to use that, there's a download. You can download the starter map. We've got the data all ready for you. But what we're going to do is we're going to draft those same descriptions that we did for the hand mapping in Chapter 6. We're going to draft them in GIS, and that's going to be the homework that we have for you. There'll be a little. I'll re-put those in a worksheet and things, but the data for ArcGIS will also be available for download. And so that's the homework, and that's the last of it. If you've got questions, if you need help, send me an email. Let me know. We can work through that. I started as a GIS guy, and so I know how to do all of that. So really, if you have any questions with Esri or GIS or drafting parcels like that, let me know and we can help answer those questions. If not, review, study up for those things. If you can do everything on the homework, you should be able to do everything on the test. And we'll break some of these things out for review, so if you ever need to use them in the future. There's also some review videos that you can use, so you don't have to watch the long drawn out versions. So that's all I have. It's been a pleasure. Thanks. Bye.